Hi, this is Cory Calcagno, and I'm doing a quick video on understanding entity relationship diagrams and how it translates into business intelligence. First, I want to briefly explain what an ER diagram is and what exactly it shows. So, entity relationship diagrams are used to plot and implement transactional processing systems that typically handle day-to-day transactions in a business, like selling products, receiving inventory, booking plane tickets, etc. The ER diagram shows all the information in a transaction that is collected and put into data tables along the way. There are four main building blocks of an ER diagram, and the first is an entity. An entity is the whole square that the arrow is pointing to on the screen. An entity is a person, place, thing, or event about which the business keeps data on. And so in business, this is customers, orders, products, vendors, etc. Think of an entity as a noun in the English language. And when put into a data table, entities become the rows of a data table. Next is the attributes, which are the characteristics of the entity. So for a customer, this would be like customer ID, customer name, customer address, city, state, phone number, etc. Product entity would be product ID, product description, product information, dimensions, weights, cost, etc. Attributes, when put into a data table, become the columns of information. Next are the relationships, and relationships are exactly that. How are the entities related to each other? Relationships are typically verbs in the English language. Customers and products are entities and are related in that a customer buys a product. Buying is the relationship. Better yet, customers, orders, products are all entities and are related in such that a customer places an order and an order contains a product. And lastly, we look at the fourth object is cardinality. Cardinality defines the relationships between entities and how many times the relationships can exist. Cardinalities can be defined by one of the following: a one-to-many, a one-to-one, a one-to-many, many-to-one, many-to-many, 0-to-1, or 0-to-many cardinalities. So this means that one, for example, one customer can place 0-to-many orders. One order can contain 1-to-many products. So I can create an Amazon account but never place an order, or I can create infinite orders. So my Amazon account will have a 0-to-many cardinality relationship to orders. And in my order, I can have one product, but I can have many different products as well on the same order. So the order to product cardinality will be 1-to-many. The next step of the equation is understanding the keys of entities. So primary, alternative, and foreign keys. The primary key is going to be like the customer ID. Primary keys are a unique identifier for a specific instance of an ID. So one customer will have one customer ID. When you create your Amazon account, that unique customer ID is going to be your email address. Now, an alternative key is similar to a primary key in its uniqueness, except that it was not chosen to be the primary key for that entity. In the same example, Amazon could create a unique customer ID number for your same account, upon registering, and that ID number could be known as the alternative key. And then lastly, foreign keys um, are primary keys from another parent or child entity. For example, in the sales order entity, there may be a foreign key for the sales rep ID, which would be a primary key from the sales rep entity. Keys are what help link tables together in the process and create tables of data. Keys help ensure that data duplication is minimized and helps join everything together. So to recap, we'll take a quick look at, kind of an extensive ER diagram here. In this example, we see entities of booking transaction, car, drivers, dispatcher, replacement transactions, return transaction, dispatch transaction. Each entity has its primary key and foreign keys listed. For example, this dispatch transaction has the dispatch ID as its primary key, and then a dispatcher ID as foreign key, which corresponds to this dispatcher table, where the dispatcher ID is its primary key. The relationships are also clearly noted, in that a car can have a one-to-one relationship with a driver, and the same thing, one driver can have one car. So how does this relate to business intelligence? Well, understanding the ER diagrams that are creating and capturing the transactions of a business will help give the insight needed to implement BI applications in the same organization. Thinking back and comparing data to information to knowledge, we have the data, which is the raw data captured from the transactional process, and it is documented by the ER diagram. From there, the information that we are understanding from the ER diagram can help us to extract, transform, and load that data and make it become information. We can do this through reporting and tools such as SQL or SQL. From there, we are able to give our users the power of knowledge to make decisions based off the information that we are providing. I use SQL on a daily basis to extract and transform data from our ERP system. We currently use a green screen AS400, which I'm showing, and it's a fantastic, almost unbeatable system at processing transaction daily, but is not a BI tool for sure. However, there needs to be a level of understanding of the data that is gathered through the process and stored in data tables to do the transformation of data into information. When thinking of the ER diagrams and these processes, it's easy to see that the different primary keys and foreign keys that are used and the attributes of the entities to transform the data as needed. For example, we sell heavy machinery. I know that each machine sale transaction processed includes a machine entity, a customer entity, a sales invoice entity, all of which have attributes to go along with it, such as customer zip code, machine models, sales prices, etc. I may want to see how many machine sales of a specific model have been sold, how many have been sold to a particular customer, or even on a particular day. And so because I understand the information that is being, or the data that is being collected from in the ER diagram process, I can extract that data and understand where to get the information from. So let's look at a quick live demo of this information that I'm discussing. The customer entity table that I was just discussing, here on the left you will see a unique identifier, which is our customer number, and then the other attributes that go along with it for customer name, customer state, address, city, zip code, phone number, etc. And then next would be our machine population table. This will have a machine unique identifier, a primary key of an ID number. This is a specific unique ID number per machine, and then again the make, model, year, location, division. These are all different attributes that we use to identify different machines, etc., in our inventory. And going back to my example about a particular machine type that was sold on a particular day, I can run, because I know where to get the data, because I understand the data and the processes that are gathering the data. I can come in and I can pinpoint that I want to see, invoices for just April 30th for a particular type of machine, and in doing so, the results I get are shown below. So we sold 1, 2, 3, 4, 5, 6 machines that are specific to the 336 type of excavator model on April 30th. And then additionally, if once we get a little more crazier into reporting and specific analysis, the sequels and the data tables and the connections get a little more hairier, and you could end up with a sequel like shown on this, that I'm highlighting at the moment right now. So this is essentially grabbing subsets of data from different tables joined by the primary keys, and then displaying that back to me. So I am currently using that last SQL statement shown to pull back customer or some transactional information to create a profit loss statement that is otherwise unavailable from our financial system. I am pulling back specific data as required and essentially populating a table simply in Excel, in which I'm running a quick pivot table and to get a summary of information, which is essentially our profit loss statement for that subset of data. And this is all in turn to help drive different decisions, help drive business decisions to help reduce expenditures and increase profitability. So the information is being provided to management to make those decisions, and hopefully in turn we'll be able to see some more a more profitable outcome on this business decision here. So understanding entity relationship diagrams has helped me as a business professional to be able to pull back information based on an understanding of our data, based on an understanding of the process that is creating the data, and it's allowed me to transform that raw data into more information that can be digested by our upper level management to make key business decisions going on and helping our company become a better place. Thank you for your time, and thank you for a great semester, for furthering my knowledge and understanding around the business intelligence and analytics world. Thank you.